Okay, today we're doing Unit 2, Lesson 4 homework, which is on page 83, numbers 1 through 6, and then number 10. So I drew the pictures out for you already, and we can look in the book for some of them as well. It's the same pictures here. Number 1 says, name the angles or segments that are congruent by the addition property. So here I drew the two pictures here for you already. We want to know which two angles or segments are congruent based on the addition property. So if I look at these and I see that D and E is congruent to C and B, right, I have this little mark here. And I see that E and A is congruent to A and B, which is what these mark, the two circles, mean. So the addition property we learned in class was that if I have two angles which are congruent, segments, added to two other segments that are also congruent, then the whole distance will also be congruent. So I can go ahead and say that this whole segment is going to be congruent to this whole segment here. So let's write that out. Segment DA is going to be congruent to segment CA. That's it. That shows that these two segments are congruent through the addition property. Let's look at part B. Here it's the same thing except we have two angles here. And again, if I look at this angle and this angle, they're congruent with one line. And this angle is congruent to this angle with the other line. And if I add two angles that are congruent to two other angles, then the entire larger angle will also be congruent. This angle here has to be congruent to this angle here through the addition property, right? If I add whatever amount this is plus that one, it's the same as adding this one plus that one. So I can go ahead and say angle JFG, which is this one here, JFG, is going to be congruent to angle JHG, angle JHG. Okay? Question 2 now. In our book here it says, name the angles or segments that are congruent by the subtraction property. So instead of adding two angles or segments, we're going to be subtracting parts of angles or segments. So here's part A. Here's our picture, and I see that R to T is going to be the same length as S to V. And I know here that S and T, if I subtract ST from both of them, if I took this part out here, I will be left with that, and so these two parts must also be congruent. So I can go ahead and say that segment RS must be congruent to segment TV. Because let's say this was 10 and this was 10. And I took out this piece here, which was 2. So then I have left 8 and 8. They'd have to stay the same. That's the subtraction property. Here in part B is we're doing the same thing with angles. I have this larger angle here is congruent to this larger angle here. And this smaller angle, which I'm going to subtract out, is going to be congruent to this same small angle, which I'm subtracting out of the bigger angle. So what's left, this piece left here that's left, must also be congruent. So I go ahead and write that angle YXZ must be congruent to angle CBD. That's it. Okay, let's look at number 3. Number 3 is going to ask us here to write a proof. It says, so let's get focus here. Right, given our givens, well, let's just take a look on our sheet. I wrote it out already. Given PQ is congruent to SR. So here's PQ, and here's SR. You see I marked them both with a circle, as the book did. And QN is congruent to RN. Here's QN, and here's RN. They're congruent as well. I want to prove that PN, this whole thing here, PN, is congruent to SN, to this one here. And you can probably see, just like we were doing before, this is going to be the addition property. So let's write out our statements and reasons. Statements and reasons. And our first line, we always have number 1, we write our givens. We know that PQ is congruent to SR. And we know that QN is congruent to RN. And our reason for that is given. Now what do we want to say here? We want to say that we can add these two together, right? That the value of this one will be equal to that one. And we're going to use our property now, which we've learned, of adding them together. So that's just our second step here. That's going to be it. We're going to say PN is going to be congruent to SN. And that is because when I'm adding two congruent segments, their result is also going to be congruent. And we call this the addition theorem, or the addition property. The addition property. Okay, let's do our next one here. I have this one here written out as well. So given TEV, here's TEV is congruent to XEW, as the book wrote. And TEW is congruent to XEV is what we're trying to prove. So again, we'll write out our statements and reasons. So again, our given is TEV is congruent to XEW. That's our only given. So what I'm going to want to do now is I'm going to want to add VEW to both. So first I have to tell you that VEW is congruent to himself. VEW is congruent to VEW. Right? And that we called in class the reflexive property. Reflexive property. Right? That something's equal to itself. So I can go ahead and add it to this one, add this to here, and add this to here as well. And then my final step is to say that TEW is congruent to XEV, and that's our addition property. Addition property that I'm allowed to add congruent angles to other congruent angles, or add segments to other congruent segments property. Okay. Question 5 here is similar, but it's with segments here instead of angles. Here's your picture, and it says given AC is congruent to DF. Didn't draw the lines for you already, but AC is this big one here. This whole thing is congruent to DF. And BC is congruent to EF. This guy here is congruent to that one there. You want to prove that AB is going to be congruent to DE. So let's write out our statements and reasons chart again. Statements and reasons. And we write in our givens first. AC is congruent to DF. And BC is congruent to EF. Our reason for that is given. Okay, we're not going to need to use reflexive property here because we have EF and BC congruent to each other, and we're going to subtract those out to be left with just the parts here that also need to be congruent, which is what we're trying to prove. That's our step 2. AB is congruent to DE, and the reason is because of the subtractive property, subtraction property. Okay, so I'll let you look at that for a second. Okay. Number 6, it tells us that GH is congruent to HK. So here's GH and here's HK. Those are congruent. And GH is going to be x plus 10. Right, then that's the value here, x plus 10. And HJ is going to be 8. And JK is going to be 2x minus 4. 2x minus 4. And we want to find GJ. We want to find this angle here. This segment here. So in order to find that, we just have to add 10x plus 10 and then add 8 to that. But I don't know what x is. But I do know that this segment here is congruent to this segment here. So I could set those equal to each other. They must be the same length. So if I say x plus 10 is equal to 2x minus 4, I can go ahead and solve for x now. Let's subtract x from both sides. And I get 10 equals 1x, or just x minus 4. And I can add 4 to both sides. And I get x is equal to 14. So now we know x equals 14. So this GH is 14 plus 10, x plus 10, which is 24. And this is 2 times 14, which is 28, minus 4, which is also 24. And that's good, that works out because we said these are congruent. They must be the same length. So to find GJ, I would just add 24 and 8, which is 32. So I could say the length of, GJ is equal to 32. And our last problem here, we're given this picture here. We're given that BAD is a right angle. Here's BAD. And we're given also that CA is perpendicular to AE. CA and AE are perpendicular. We know those are actually also both can make right angles as well. And we want to prove that BAC, this one here, is congruent to this one here, EAD. So let's write again our statements and reasons. And first write our givens. BAD is a right angle, and CA is perpendicular to AE. and that's given. So I know both of these are going to have to be 90 degrees. So let's write that out. How do we know that? I could say angle BAD is 90 degrees because that's a definition of a right angle. Definition of a right angle. And I know that the measure of angle CAE, where these two perpendicular lines cross, measure of CAE must also be 90 degrees. And our reason for that is two perpendicular lines make a 90 degree angle. We could say that's the definition of perpendicular lines. Of perpendicular, you can just write it like that. And then I could say they're now congruent, right? So number 4, measure of angle BAD is equal to the measure of angle CAE, because that's the definition of congruent. Right? Two angles of the same measure are congruent. Definition of congruent. So now I know these two are congruent, which maybe you saw from the very beginning. But now what I want to prove now is BAC is going to be the same as EAD. So I just have to subtract from both of them this one, CAD. So remember, we have to use the reflexive property when we're subtracting something from itself. And I have to say angle CAD is going to be congruent to angle CAD. And that's our reflexive property. And then our last step then is to prove what we want to do. Angle BAC is going to be congruent to angle EAD. Right? And there we're using subtractive property. We're taking this part out and we're saying BAC is going to be congruent to EAD without that piece in the middle, without the CAD in the middle. So that's the subtraction property. Okay, let's move this up so you can see. Sorry. And this was a lot of steps. It could be that these steps, all the way here, we could have combined into smaller amounts, or the truth is, a lot of these we don't have to define them each time. We know what a right angle is 90 degrees. But these were very important. This is what we're working on today, the reflexive property and then the addition and subtraction property, that we're mainly focusing on.